think the stage is yours.
Thank you very much. Okay. Hello everyone. My name is Andrea Fieschi. I'm doing my PhD in collaboration with Mercedes-Benz and the University of Stuttgart. And I'm here to present this paper that I wrote with my colleague, Yunxuan. My job today has been made substantially easier by the fact that yesterday we heard two very interesting talks about connected vehicles. We've heard about the project of software-defined cars, and both my colleague and I are involved in the project. The topic of our paper is the specific aspect of privacy in connected vehicles, and we wanted to explore a little bit the perspective that drivers and car manufacturers have, or users and service providers. So we've seen already yesterday how many different kind of usage we can have from data that we collect from cars, how much of an important source of data vehicles are. We can use them for many different things, for improving autonomous driving, for trying diagnostics, for having some real-world experience instead of a simulation, trying to see, as we saw yesterday, for the MBUS, for the infotainment system, how we can improve it and all. We have an infinite amount of different use cases and different data sources. The connected vehicle environment is very big and is composed by different kind of vehicles. The cloud, different kind of clouds, roadside units, which could be like smart traffic lights. We can have smart charging station. The possibilities are very variegated, and for the purpose of this analysis, we decided to focus on the connection between vehicles and the cloud. The problem is already complex as it is regarding privacy, so we decided to start from that direction. Why is privacy important for connected vehicles? We know that cars are strongly connected to our habits as drivers. We can see here a very simple example. We drive from home to work, then from work to the hospital, or maybe we go to a pub, or maybe we go wherever we decide to go. We do it at a very specific time, and having all those information can lead to privacy issues. So the car manufacturer, the privacy as a whole, and the driver are the main characters of our paper, and we can start with the perspective of the car manufacturer or service provider more in general. Why is privacy important for car manufacturers? Well, data are important in order to monitor how the product is performing, how to maybe develop a new product, and how to maybe improve the next iteration of the application or the physical product. As we were saying before, connected vehicles, data that we connect through this environment can lead to privacy violations, and there is a strong interest from the service provider to provide strong privacy policies for three main reasons. One is an ethical consideration. A car manufacturer is made of people, which end up being drivers themselves, and are interested in offering privacy protection. Then there's the aspect of fostering customer trust. Without trust, products cannot be sold by the service provider or by the car company, and agreement on data sharing cannot be met. And then there's the aspect of legal compliance that at least zeroes out all the car manufacturer and service providers on a basis of privacy protection. This here is a simplified version of the data stream that a car manufacturer sees. We have a cloud where we receive data from, for example, from a specific vehicle. We analyze the data, we perform we run some algorithms, and then we can decide either to send data back specifically to a specific car, to an identifiable vehicle, or to send it back to the whole fleet, for example, through the rollout of the update of a new application. Now we can divide these two streams and identify two different challenges. On the left-hand side, we can see user-specific applications, so applications where we collect data from a specific vehicle, we analyze the data, and then we send them back to the same vehicle. Those are not anonymizable, so we need to find some different kind of data protection for those specific use cases. And on the right-hand side, we have user-independent use cases, so we're just collecting general data from the whole fleet, and then we analyze those, and we send them back. We roll out the update to the whole fleet. Then we have the big problem that data use cases are very different. They have different privacy needs, so there's not a one rule fit them all. And there's also the problem of privacy concerning also individuals that are external to the vehicle. For example, if we collect camera data, we also have the problem of risking to violate someone's privacy, and it's an individual who didn't sign any sort of terms and condition and has no actual relation to the vehicle itself. So how can we try to approach data protection, and what are the methodologies that we can use? We can use data minimization, for example, and I don't mean just the one required by law. I mean actively trying to collect the lowest amount of information that we need just to perform a specific task, and trying to bring it back to the bone, just bring it down to the bone, so we don't risk collecting further information that might lead to privacy violation. Then we can have data suppression, for example. We can generalize data, trying to achieve k-anonymity or t-closeness, L-diversity, going in that direction, trying to group and aggregate the information so they're less specific but still informative for us. We can have differential privacy. I don't know how many are familiar with differential privacy. It's just trying to de-identify data at noise that whose distribution we know, and then have a data set that is affected by noise that we can compensate for, and still if an attacker manages to connect one data entry to a specific data source, they would never know if the data entry is affected by noise or not. We can have homomorphic encryption, for example, which allows mathematical operations to be performed without decrypting the data entry itself, sending it back to the source, and then the decryption happens back on board. Or we can have, for example, use as an approach federated learning. So how can we synthesize the main approach, we can approach as our car company can approach all those challenges? The way of prioritizing privacy protection should be done through a transparent data collection and a transparent communication with their customers, making clear everything that happens and making the information available of how this whole thing happens. Making sure that the communication channel is at least secure and it doesn't risk to expose an extra, or at least to become like an extra risk of exposure for the customers. Trying to improve on data minimization, and again, not only the legal required one, and trying to explore and experiment with different privacy enhancing techniques. There's also this very important aspect that there is a trade-off between privacy protection and kind of service. And I don't mean quality of service. It doesn't mean that the quality has to be worse. It's just the kind of service is very different, and that needs to be understood. If you need a strong privacy protection, then we won't have very specific and very tailored services, but we can have something that works for most people and can be as personalized, maybe just not as personalized, but it doesn't have to be of lower quality. We can now pass to the driver side and see how the driver sees the whole environment. And we can see here that us as users, our drivers, we tend to see the vehicle as something that is a physical device, as something that we control and we have hands on. So it's the side of the environment that is trusted and secure. We can decide not to share the car with other people. We can trust in the fact that the data stays there. And then there's the rest of the environment, which is the cloud, which is an environment that the driver assumes to be honest, because otherwise they wouldn't share data with this cloud, but also curious. So there's this element of curiosity that pushes the data consumer having access to this cloud to try to find more information, statistical analysis, and not necessarily something that harms the user, but it's still some extra curiosity. So the challenges for the users, or that we need to address in order to meet the user's need, are again trade-off between privacy protection and service quality and kind. So some users might want a stronger privacy protection and a different kind of service that is not as personalized. So we need to have different privacy enhancing techniques that would meet most needs of very different users. Then we have the fact that the context can change, and privacy protection is context dependent. In case of an emergency, most of us would just want to be rescued instead of just having their privacy highly protected. So that's also something that needs to change and be dynamic. And then there is the problem of the overhead that this privacy protection and this transparency can be for the user. It's very nice that we try to make clear and have the user informed of what happens, but we've all seen it with, for example, the cookie disclaimer of every website, where it's just for every website there's a long list that we need to read, and most of us end up just not reading it. So something that is user-friendly, that makes it's not as fine-grained, but still allows the user to specify all their needs, would be the perfect situation and the perfect solution. So we can simplify this whole situation in explaining to the driver how the whole world goes. Not the whole world, but the whole connected vehicle environment can be seen. So we can call the side of the device, the side of the vehicle, as something that has hard privacy. The data are there, and it's up to them to do what they want with it. They can be protected, they can be encrypted, so also if someone has some physical access to it, they're not as accessible, so there is a harder privacy. And then whatever they share, there is what we can call soft privacy. So it is still protected. There are higher risks, of course, but there are privacy agreements that can be signed between the two parties, that are different PPTs that can be applied, that can be a way that the driver can, and user, all of us as users, can understand privacy in this environment. So the main point that my colleague and I wanted to bring forward is just that the view of the car manufacturer and the driver is substantially the same when it comes to privacy. The views are not opposed, they're not diametrically different, they are exactly the same, both parties value it. We just need to have more collaboration, more transparent communication between the two. Make sure that privacy caters to both parties' needs in order to have something that ends up being satisfying for everyone, can be actually applied, and can actually bring some benefit to all of us in the connected vehicle environment. So our future work will, in our future work, we'll try to conduct some user studies in order to understand what the driver actually needs, what are their requirements, and what is their understanding, their general understanding of privacy and data collected from cars. We'll try to understand what is the view of car manufacturers and the legal requirements that they have. We'll try to see what are the PETs present in the literature and how we can transport it to the car connected vehicle domain, see if there is a direct mapping, how many adaptations we need to do. And then we'll structure all of our work in a framework of privacy by design. It's the only way of making sure that every need is met, that every use case, as different as it is, can be actually protected efficiently. thank you very much for your attention. And yeah, we can talk on Friday. Or yeah.
Very quick question.
One quick question.
Typically, the question is during the poster session.
Okay, that's fine.
I apologize, yeah.
Yeah, that's fine.
Okay. So then
I'll write it down.
Your further boss. Nothing more to say?
To take the drinks, that's okay.